Before we get into simplifying algebraic expressions, just a little recap on some terminology related to expressions and some properties of algebra. So just a reminder that when we're dealing with expressions, really we can divide that into two different types of expressions. So the first type of which is a numeric expression, and the second of which is an algebraic expression. And so if this circle represents all of the expressions that are algebraic, completely contained inside of that are the numeric ones, because in order for an expression to be algebraic, it can contain variables and then also contain numbers and then some sort of operation symbols. But numeric expressions are the ones that contains only numbers and operation symbols, not variables. So as an example, something numeric would be like 8 divided by 2 plus 4, because that's using division and addition and just numbers, no variables. Whereas something that's going to be algebraic might have some variables involved, so like x squared minus 5xy plus 10, something like that. And then we give some terminology to different sorts of algebraic expressions that I just want to highlight here as well. So recall that anytime you have subtraction or addition between different things, then that separates different terms of an expression. So this guy right here, and this guy right here, and this guy right here, they are all terms of the expression. So this expression is a three-term expression. And then any term that has variables in it, then whatever number is timesing with that particular term is called the coefficient of that term. So there's only two of these terms that actually have variables. So therefore, this -7 and this 12 are going to be the only coefficients, because those are the only numbers timesing with variables. Whereas that -8, not a +8, that -8, we term that a constant. So any number that is just added or subtracted to an expression that doesn't have any variables involved, we'll just refer to that as a constant. And then of course you guys know that these guys right here are variables that are just representing some sort of an unknown quantity. Excellent. All right, and then just a few properties, some of which we're familiar with, that are a good recap, and then some that are new, but should be pretty clear to understand here. So the definition of subtraction is that if I want to take some number x and subtract y, we actually define that again based off of addition. So recall that it's actually the same thing as adding the opposite. So whereas we were trying to subtract a positive y, now what we're doing is now we're adding a negative of that number, so the opposite of that particular number. Similarly, we define division in terms of a different operation, multiplication. So recall that x divided by y is actually the same thing as x times the reciprocal of y, which is going to be 1 over y always. So you can see there that instead of dividing, we've actually changed that to multiplication, and then rather than use the there we go, the original number that we were trying to divide by, now we're going to multiply by the reciprocal this time. All right, and then for distributive property for subtraction, note that we only ever defined the distributive property when we were adding, so there's a little blank space up here. So recall that this right here is the distributive property, right? So the A would distribute to the B and to the C, and we'd add those terms together, right? So we haven't defined that for subtraction, but it does end up holding that if we were to take A and then distribute it to a subtraction of two different terms, that we can distribute there, and what it will end up equaling is we'll end up equaling A times B plus, subtracting A times C. And the reason why that is, I'm going to kind of show some steps to work ourselves there, is that I can rewrite the B minus C as B plus -C. And so therefore now with that plus, now we can use the distributive property that we actually defined, and then we can distribute the A to the b, and then the a to the negative c, which would give you a times b plus a times negative c. But then since the a times negative c is negative, then we end up with our kind of result right there. These ones we've talked about already. We know that multiplication by 0 is going to give you 0, and multiplication by -1, so x times -1 just equals the opposite of the number that you were multiplying by. Okay, opposite of a sum, right? So if I want to take a sum and find its opposite, so that means we need some sort of a sum, so x plus y, and if I want to find the opposite of x plus y, I need to negate that entire sum, and so what that would look like is it looks like this. And then really it's just actually using the distributive property, because that negative is a -1, which means that the opposite of a sum is actually -x minus y, if the sum was x plus y. Opposite of a difference, so a difference, right, is subtraction. So if you have an x minus y, and then you were to take the opposite of that difference, then you negate that entire subtraction, which would end up giving you a -x plus y, basically distributing that -1. Opposite of a product, so a product, of course, means to multiply quantities, and so then if I wanted to take that and negate that, that's going to be the same thing as just -xy. And then finally, opposite of an opposite. So if I have some number like x, right, but then I was going to take the opposite of x, then I'd have -x, and then I want to take the opposite of that opposite, so do a negative of that opposite, and that's going to give you kind of the original number that you had to begin with that wasn't its opposite.